So in this video, let us discuss about logarithmic shifters. So basically, we have designed about the later class. Um, we have discussed about barrel shifters, which implements the shifter using a single array of past transistors. So here it uses a staged approach. Okay, logarithmic approach uses a staged approach. So if suppose if the total shift values decomposed into shift over power of 2. Okay, so the total shifter values is decomposed into shift over power of 2. So suppose if I want to shift 8 bit, okay, if I want to shift the 8 bit means um, it has to be 2 power 3. Okay, so here the 3 represents stages. Okay, so here if I want to implement the shifter with a maximum shift width of m. So if the maximum shift width is of m, it consists of log 2 of m stages. So here you have, this is 3. If I want to get this value is equal to 3 stages, m value must be 8. Okay, so here the I is 0 value. So 2 power 0 value is 1, and 2 power 1 value is 2, and 2 power 2 value is 4. Okay, so this represents stages. Okay, and this one represent power values, 2 power 0, 2 power 1, and 2 power 2 value. Okay, so you can shift the values from you can shift the values from 0 to 7 bits using this these stages. Okay, so if I want to shift suppose if I want to shift 6 bits means the 1 as in simply it will pass the value. Okay, pass the value, and these two are in shift mode. Okay, so if these two will get shift, you will get the 6 value. Okay, so the first shade in the pass mode, and the second and third stage should be in the um, shift mode. So the greater advantage of this logarithmic shifter is no decoder is required. Since no decoder is required, it occupies very less space compared to the barrel shifter. Where in the barrel shifter you require a decoder, right? So barrel shifter is used in the smaller circuit, whereas this logarithmic shifter is used in the for a larger value. So okay, so The applications of this logarithmic shifter is it is used in the bit reversals, shuffles, and interchanges and all. Okay, so this logarithmic shifters mostly used. Okay, is mostly used and it is easily generated, right? So let us discuss the log diagram of the logarithm shifter with a with those 7 bit. Okay, it is nothing but a right shifter. Okay, uh, so here I have shown only the um, least significant bits. Okay, so let us take A3, A2, A1, and A0. So um, we need to shift. It will shift 0 to 7 bits, right? And this A0 to A3 is a least significant bit. Okay, so so I have already told you this is 2 power 0 value on the so this is my first stage. Okay, so in the first stage you have two shift operation will be performed. So one it will so let me term that one as sh 1 bar. Okay, so 2 power 0 represent 1, right? So whenever this value this sh1 bar is 1, so a3 value will just pass. Okay, similarly for this also. Okay, so if sh1 bar value is equal to 1, this will simply pass this value. Okay, and suppose what happened to um, 1? Okay, I have used two shift values. If sh1 is equal to 1, then what will happen? This bit, whatever the value that is a4, whatever that I am giving, will reach here. Okay, so the a4 value will comes here. So it is shifting um, uh, to the right. So similarly, you can see. So if sh1 value is 1, a3 value will reach the each k. Hello. Similarly, hmm, so the a2 value will reach here. Okay, and the a1 value will reach this side. Okay, so if sh1 is equal to 1, it will shift the value 1 bit right. Okay, if sh1 bar value is equal to 1, there will be no change. So this is about the first stage. This is a stage 1. Okay, so next let us discuss about the stage 2. So this is my stage 2. Okay, so this is nothing but 2 power 1 value, that is 2. Okay, so here also I have two two values. Okay, so let me name it as sh2 bar. Okay, so let us assume this is here the one is 1. So if sh1 is 1, you will get a3, a2, a1 and a0, right? So here this will shift either uh, if sh2 is equal to 1 means this will simply pass this value. Okay, if sh2 is 1, right? If sh2 is 1, you will get a3, a2, a1 and a0. Okay, suppose um, then what will happen, my a5 bit, right? Hmm. So this is my a5 bit, right? A5 bit, this is a4 and this is a5 bit. So a5 bit will come here, right? And here this one, and a6 bit. So the a6 bit will reach here. Okay, because it is shifting two values. Okay, so if sh2 is 1, it will shift two values. So if it shift two values, initially you have a5 here, right? And this is my a6. So the a6 value will reach here, and my a7, a3 value will reach here. Then a2 value will reach here. Okay, so this is about the second stage. Okay, so let us think here. Uh, Here my sh2 is 1. So I'm just writing this a3, a2, a1 and a0. Okay, so again during the s- third stage, for the third stage, for the third stage, if suppose my sh, so this is nothing but stage 3, 2 power 2, that is equal to 4. So here sh4, so sh4 bar is equal to 1. So sh4 bar is equal to 1, you will get a3, a2, a1 and a0. Okay, so what happens when sh sh4 is equal to 1? So if sh4 is equal to 1, so here you had so if sh4 is equal to 1 means so here I had 4 values, right? So I have taken So if I shift 4 values means this has to come below this. Okay. So this has to be uh, so this has to be, so let me assume this is a song, and you have so mm, so again so this is about this one, and here get out this value. So if I shift the 4-bit value means this becomes your, this is nothing but your A4 value, right? So this is nothing but A4 value, and this must be A5 value, okay, and this is A6 and this is A7. Okay, so output I can represent it as B3, B2, B1 and B0. Okay, so I'm going to take the output. Okay, so the output is taken from since I need B minus one value, and this is B minus 2, and this one is nothing but B minus 3. Okay, and this is B minus 4. Okay, and I can take second shift 7 bits value, like 1, 2, 3, 4, 5, 6, 7. If it is 1 bit means it gets shifted here 2, 3, 4, 5, 6, 7, and the 8th one is here. Okay, V of minus 5. Okay, so the further shift means the output is from here, right? This is my B of minus 6. Since this output is already connected here, okay, and can see this is my B of minus 7. Okay, so what is logarithmic shifter is, if you see if I have A3, A2, A1, A0, okay, it is 1, 1, 1. Suppose if the input is 1, 1 means this is my output. Okay, if it is shifting by 1 bit means the left hand side bit, most infant bit is filled with 0. Okay, so the rest of the bit is shifted towards right. Okay, this is for shift 1 value. Okay, suppose if it is shift 2 means 2 bit get 0, 0, and the rest of the value get shifted towards right. Okay, so these values get changed, interchanged, right? So they haven't given the values for like a A5 and all, they haven't given, okay, in your book. So for only understanding purpose only, I have written this values. Okay.